In this video, we will find the value of a trigonometric function at a special angle. Special angles will be multiples of pi over 6, pi over 4, pi over 3, or pi over 2, also known as 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So, as long as we have a multiple of these, we can easily find the value of any trig function. Look at number 4. We want to find the cosine of negative 5 pi over 6. Wait, before I go any further, please make sure you have memorized these values to the point where at the beginning of any trig assignment you can immediately write down these 6 values in a table like I just did. You should definitely memorize the 3 yellow ones, and then you should be able to get the white ones, because these are just the same as these, only backwards, and this one is the same as this one. So for the rest of this video, I'm going to assume that not only have you written these down, but you know how to write them down from memory without a cheat sheet of any kind. So when I look at this, I say to myself, what is the reference angle? And it's pi over 6, so that's my reference angle. So let's just keep that in mind. Reference angle pi over 6. So with that in mind, a sketch will be helpful, because I know that the cosine of this angle is going to be the same thing as the cosine of the reference angle. Okay, I'll just write it like this. So it'll be the same thing as the cosine of the reference angle pi over 6, give or take a minus sign. Depending on what quadrant it's in, I might have to put a minus sign on this. So the quadrant is going to tell me, so that's why I need to do a sketch. So here's my sketch. Alright, so far that's pi is the upper hemisphere there. But I need to draw pi over 6, so I need to split it up some more. I need 6 parts, I need 6 parts up here because it's pi over 6. So far I have 2. So I will split this up into 3 more parts, like so. And I'll do the same thing right here. Okay, so now these are all pi over 6s. So if I were to start out here in standard position, positive x-axis, and then proceed to go negative 5 pi over 6. Alright, that's in the clockwise direction, is the negative directions. So that would be negative 1, 2, 3, 4, 5. I would land here. So here's a sketch of negative 5 pi over 6. There you see it. But the terminal side is in the 3rd quadrant. Now the cosine on the unit circle is the x value, and x values are definitely negative in the 4th quadrant because they're to the left. So I will need to stick a negative on here. Now we have memorized the value of cosine pi over 6. Remember, cosine of pi over 6 is radical 3 over 2. Alright, that should be straight off the dome, the cranium. So this is going to be negative radical 3 over 2. Kabam! That's it. Let's do the same thing with number 5. Cotangent of 5 pi over 3. Well, start with the reference angle. The reference angle is pi over 3. So this is going to be the same thing as the cotangent of pi over 3, give or take a negative sign. It might need a negative sign on it. Now this is going to be the same thing as the tangent of pi over 3, except for tangent is the reciprocal. So if I can find the tangent of pi over 3, which I can, I will just turn it upside down, and then that will be the cotangent. So let's do this. Let's go ahead and find the tangent of pi over 3, and then we'll worry about the signs and stuff. So the tangent we know that tangent is sine over cosine. So this will be the same thing as the sine of pi over 3 over the cosine of pi over 3. Now we are ready to rock and roll with our 6 values that we wrote down, because these are 2 of those 6, aren't they? So sine of pi over 3 is going to be 1/2. False. It's going to be radical 3 over 2. Okay, and the cosine of pi over 3 is going to be 1/2. Okay, almost messed it up, but sine of pi over 3 is radical 3 over 2. Cosine is 1/2. You should be able to pull that right off of your memory, but if you need to write it down, so be it. So it's just a matter of what are the signs, all right? Are these positive or negative? Now's a good time to talk about that. And to figure that out, I'd like to draw a picture like you do. So here's my picture. So here's pi. Now I'm shooting for pi over 3 reference angle. So I'm going to split this up into 3 parts like this. Okay, see how the top hemisphere has 3 parts? That means it's pi over 3. Yeah, so if I go 5 pi over 3, let me show you what that's going to look like. So here's my standard position, and so I'm going to go positive direction 5 pi over 3. So that's 1, 2, 3, 4, 5. So that puts me here. Boy, I'll say boy. That puts me here. Okay, so this is a picture of 5 pi over 3. This is in the 4th quadrant. Alright, it's a little bit to the right. If you need to draw in your y-axis to make it more clear, you know what, you knock yourself out. So you see we're in the 4th quadrant. In this quadrant, the sine function is going to be negative, alright, because sine is a y value, and y values are negative down below. So the sine is going to be negative. The cosine function, because it's an x value, over here to the right as we are, will be positive. So this is going to stay a positive. The cosine will be positive. So overall, a negative divided by a positive is going to be a negative. Okay, so it's going to be a negative something, alright, which tells us that we're going to need, technically this should be a negative tangent pi over 3 back here. Anyway, the 2's in the denominator will cancel out, and it's just going to wind up being radical 3 over 1, which is just radical 3. So it'll be negative radical 3. Okay, that is the value of negative tangent pi over 3. But we want the cotangent of, okay, and this has to be negative 2. We want the cotangent, so we need to do the reciprocal of this thing, okay, for the cotangent. So that's why the cotangent, and the true answer is going to be, should I make an arrow or something? The reciprocal of this is just me putting a 1 over it. So it'll be 1 over negative radical 3. So this will be the final answer. Okay, let's do it again. Tangent of 9 pi over 4. Okay, this is a special angle, pi over 4. So clearly the reference angle is pi over 4. Okay, so that means this will be the same thing as the tangent of pi over 4, give or take a negative sign. Maybe it's negative, maybe it's positive. I don't know yet. I can figure that out though. So let's think about the fact that tangent is sine over cosine. So this will be the same thing as sine pi over 4 over cosine pi over 4. And we have memorized these, so we know that the sine of pi over 4 is 1 over radical 2, or some people like to say radical 2 over 2, which is the same thing. Cosine of pi over 4 is also 1 over radical 2. So it's just a matter of whether or not these are positive or negative. So to figure that out, I say do a sketch. So here's a picture. Here's pi over 2, and here comes pi over 4. Okay, if I start off in standard position and I want to go 9 pi over 4, that's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 pi over 4 is actually right here in the first quadrant. So in the first quadrant, sine and cosine are both positive. Alright, so that means tangent overall is going to remain positive. So no need for a negative sign. But anything divided by itself is 1. So that means this is going to equal 1. And so that's going to be the answer. Yeah, we don't need to do the reciprocal or anything because we started with tangent and we have tangent. So the answer is positive 1. Okay, looking at number 7. Secant. Alright, pi over 2. Alright, we don't need a reference angle or anything for that. Pi over 2 is what we are going to deal with. So just let us understand that the secant is the reciprocal of the cosine function. So let's figure out what the cosine of pi over 2 is, and then whatever that is, we'll do the reciprocal of it. So cosine of pi over 2, you'll notice that it is not on our little chart here. We don't have pi over 2's here. The reason why is because it's all about a sketch when you're thinking about pi over 2. Alright, because here's pi over 2. Or these points, alright, all of these pi over 2's, it's all about coordinates. Alright, like this point is the point 1 comma 0, and this is 0 comma 1, and negative 1 comma 0, and 0 comma negative 1. Now the cosine on the unit circle is the x value. So that's the cosine, that's the cosine, that's the cosine, that's the cosine. Alright, it's all the x values. So when you ask yourself, what is the cosine of pi over 2? All you have to do is look at pi over 2. And pi over 2 is right here at the top. And you see that the cosine is 0. Okay, now the secant is supposed to be the reciprocal of that. So the reciprocal of 0 is this crazy notion of like 1 over 0. But I hope you understand that 1 over 0 would be undefined. Okay, you can't take the reciprocal of 0. So that's your answer. The secant of pi over 2 is undefined. Alright, what about number 8? Sine function. Take a gander at that reference angle, pi over 6. So this is going to be the same thing as sine pi over 6, give or take a negative sign. We might have to make it negative, we might not. We can figure that out real quick by looking at a sketch. So here it is. There's pi over 2. If I split this up a little further, I can make it into pi over 6's, like I so often do. Okay, it doesn't have to be perfect, he said as he drew a super crooked line. So these are pi over 6's now. If I want to go 5 pi over 6, then start from standard position. Okay, there's 1, 2, 3, 4, 5 pi over 6 would be right there. Okay, that puts us in the second quadrant. The sine function is a y value on the unit circle, and so it will be positive up here because it's above the x-axis. So that means it's going to be positive, so we don't need to change the sign. And sine of pi over 6 is one that we have memorized. It is equal to 1/2. So that's just plain the answer. Alright, remember, sine of pi over 6, 1/2. We got it. So that was number 8. Alright, for number 9, 9 pi, well, that's just a nice even multiple of pi. So let's just look at our unit circle immediately. So look, guys, here's pi right here. So if I were to start in standard position, alright, starting from right here, just count with me. If I went to here, that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. So can you see that 9 pi is going to land at pi? Okay, it's going to land right here. So what is the sign at this position? Well, when it's right on the axis, what we do is we use the coordinates. So the coordinates over here at this point are -1, 0. The sine function is a y value on the unit circle. So that is the value right there. So that's it. The sine of 9 pi is simply 0. Okay, what about number 10? Pi over 2. Alright, again, it's all about the picture. So let's just go straight to it. Here's the picture. These are pi over 2's that you're looking at. If we start off, okay, standard position, we're going to go 3 pi over 2. So that's 1, 2, 3 pi over 2 is right here. Okay, that puts us right here as far as the terminal side. When you're dealing with being on the x-axis or the y-axis, it's all about using the coordinates. Alright, the coordinates of this point are 0, -1. Now on the unit circle, the cosine is an x value. So that means kabam, that is the cosine of this angle right here. So that's it. Cosine of 3 pi over 2 is 0. Lemon squeezy, easy peasy. Tangent of 5 pi over 2. Well, the thing that you have to keep in mind for tangent is really just that it is sine over cosine. So as we do this, we're going to be saying this will be, well, you know, maybe I'll leave the space empty. But so tangent of 5 pi over 2 is going to be sine of 5 pi over 2 over the cosine of 5 pi over 2. So once I figure out what that is, that'll be my answer. And to figure out what this is, again, it's all about the picture. So pi over 2's are just half of pi. So the upper hemisphere is pi, so split in half, you got pi over 2 on each side. So I need to go 5 pi over 2 to see what I'm dealing with. Starting from the standard position, positive x-axis, we're going to go 5 pi over 2. So 1, 2, 3, 4, 5 pi over 2 puts me right here Yeah, so here's my terminal side that I'm dealing with. So when you're on the y-axis like that, it's all about the coordinates. This is the point 0, 1. So the x value is the cosine, and the y value is the sine. So that means, back to this, the sine is going to be 1, alright, because there it is. The cosine is going to be 0, because that's the x value. So that means this tangent guy has a value of 1 over 0, but hopefully it jumps out at you that this is undefined. Can't divide by 0. It's craziness. So two more examples. I misspoke. So sine of 7 pi over 3. This is a special angle. So let's deal in terms of the reference angle. So this should be the same thing as the sine of pi over 3, except it might be the opposite sign. Alright, it may need a negative sign right here. I don't know yet. The way I can come to know is by drawing a picture. So that's what I'll do. So here's pi. I need pi over 3's. So I'll split the top into 3 parts, because that will be pi over 3. So now I have pi over 3's. Starting in standard position, okay, I need to go 7 pi over 3. So here I go. 1, 2, 3, 4, 5, 6, 7. So 7 pi over 3 is right here. So is this positive or not? We're talking about the sine function. The sine function is a y value on the unit circle. So up here, y values are positive because we're above the x-axis, which means that it will be the same. 7 pi over 3 and the sine of pi over 3. I don't need a negative sign here. So what's the sine of pi over 3? It must be radical 3 over 2. In my mind, I'm thinking, I know the sine of pi over 6 is 1/2. So the sine of pi over 3 must be the other one, which is radical 3 over 2. Okay, kabam. And that's it. That's the answer. Alrighty then. Now this is the last example. Cosine of negative 5 pi over 4. So clearly the reference angle is pi over 4. So this should be the same thing as the cosine of pi over 4, give or take a negative sign. Maybe I need a negative sign, maybe I don't. The way I can figure out if I need a negative sign is once again draw a sketch. Here's pi, upper hemisphere is pi. If I split it again, that's pi over 2, half of pi. If I split those, I will have pi over 4. So that's what I'm going to do. Alright, see how I have 4 pieces in the top? That's how I know it's pi over 4. So we need to go negative 5 pi over 4. Start off in standard position, and negative 5 is clockwise. Is it negative angles or clockwise? So here I go. Negative 1, 2, 3, 4, 5 will be here. Okay. So is cosine positive or negative in this quadrant? Well, remember that cosine is an x value on the unit circle, and x values are negative over here to the left of the y-axis. So we will need the negative sign on this. So what is the cosine of pi over 4 though? We've memorized this. This is 1 over radical 2. okay, or some people say radical 2 over 2, and that's the same thing. We do need the negative sign as we discussed, so it'll be negative 1 over radical 2. And that's it. All right, here endeth the lesson.